Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0366, indicates an incorrect phase detected between the Camshaft Position, CMP sensor B, and the Crankshaft Position, CKP sensor in Honda Accord models from 2017 to 2023. This malfunction could lead to engine performance issues, including stalling or misfiring, if not addressed promptly. To understand the gravity of this error, it's important to know that these sensors are crucial for monitoring the engine's position and timing, which ensures optimal timing for fuel injection and ignition. The CMP sensor B is usually located on the cylinder head, while the CKP sensor is located near the crankshaft, typically at the engine's lower front. These components work in tandem to provide the Engine Control Module, ECM, with the necessary data to manage engine functions efficiently. Anomalies detected by these components can cause the ECM to miscalculate engine timing, ultimately leading to reduced engine performance. DTC P0366 pertains to a discrepancy detected between the Camshaft Position, CMP sensor B, and the Crankshaft Position, CKP sensor. The CMP sensor B's role is to monitor the position of the camshaft, providing critical information to the Engine Control Module, ECM, related to valve timing. This sensor is often located on the cylinder head of the engine. On the other hand, the CKP sensor measures the position of the crankshaft, which is pivotal for ignition timing and fuel injection calculations. The CKP sensor is generally found at the engine's lower front, adjacent to the crankshaft. Both sensors are integral to the Variable Timing Control, VTC system, and issues with either can lead to significant engine performance degradation. Proper functionality of these sensors ensures that the engine operates smoothly and efficiently, impacting fuel economy and emissions. The possible causes for the DTC P0366 can be categorized into three main areas. First, there might be faulty CMP sensor B and CKP sensor. They can fail over time or develop internal issues that lead to inaccurate readings. Second, wiring issues such as short circuits, frayed wires, or poor connections can disrupt the signals sent to the ECM, leading to incorrect phase detection. Lastly, timing misalignment can occur if the camshaft and crankshaft are not synchronized properly, possibly due to a worn chain or incorrect installation. Each of these causes can undermine the operational reliability of the engine, necessitating a thorough investigation and rectification to restore proper functionality. Symptoms associated with DTC P0366 include a rough engine idle, which may manifest as shaking or vibrations at a standstill. Drivers may also experience poor acceleration, where the vehicle does not respond as expected when the throttle is pressed. Additionally, the check engine light, CEL, will illuminate, alerting the driver to the presence of a malfunction in the vehicle's engine management system. These symptoms not only compromise the driving experience, but could lead to more severe issues if the underlying cause is not promptly addressed. Recognizing these signs early can save time and costly repairs down the line. The first troubleshooting step involves initiating the vehicle's electronic systems. Begin by turning the vehicle to the on mode without starting the engine. Next, connect a Honda Diagnostic System, HDS, to clear any existing Diagnostic Trouble Codes, DTCs. Once cleared, turn the vehicle to off, lock mode, and wait for the engine to cool down below 104 degrees Fahrenheit, 40 degrees Celsius. After allowing the engine to cool, start the engine and let it idle without load, ensuring that the continuous variable transmission, CVT, is in either park, P, or neutral, N, or the manual transmission, MT, is in neutral. Finally, check for any pending or confirmed DTCs using the HDS. This step is crucial as it initializes the troubleshooting process and allows verification of the issue. During the second step, you will conduct a variable timing control (VTC) system check using the HDS. Start by selecting the VTC test in the function test menu and choose the EX VTC option. The HDS will perform a series of diagnostics on the VTC system to evaluate its performance. If the result from this test is okay, you can proceed to the next troubleshooting step. If the results are not satisfactory, this indicates a deeper issue in the VTC system, necessitating further examination. The VTC system plays an essential role in optimizing engine performance by adjusting the timing of the intake and exhaust valves. So any discrepancies must be resolved to ensure engine efficiency. In the third step, the aim is to verify the status of the VTC system under real driving conditions. Test drive the vehicle at a steady speed, ideally between 19 to 38 miles per hour, 30 to 60 kilometers per hour, for around 10 minutes. This will help capture any variations in the VTC mechanism during normal operation. After the test drive, use the HDS to check the EX VTC status against specific threshold values that the system should meet under those conditions. If the current conditions match the expected threshold, continue on to the next troubleshooting step. If not, retest the vehicle to gather more data on the VTC status. This step is essential for ensuring that the VTC system is functioning correctly in conjunction with the engine. Next, monitor the onboard diagnostics (OBD) status for DTC P0366 using the HDS. This step is crucial because it allows you to gauge the performance of the system and determine if the error has persisted. The primary question here is whether the HDS indicates a failed status. If it does, that suggests continued issues with the engine timing synchronization, prompting a need for further investigation. If the status indicates passed but points to intermittent failure, the system may be temporarily functioning without issues. In such cases, it's essential to try to replicate the original conditions under which the fault was first detected. This monitoring is vital in establishing a clear pathway for further diagnostic actions. For the fifth step, you need to check the operation of the Variable Timing Control (VTC) Oil Control Solenoid Valve (B). This component plays a vital role in controlling the flow of oil to the VTC system, which intrinsically affects camshaft timing and thus engine performance. If the solenoid valve operates correctly, you can move on to the next troubleshooting step. If it is found to be defective, a replacement is necessary. Addressing the condition of the solenoid ensures that the entire VTC system functions as intended, preventing any detrimental impact on engine operation and longevity. The sixth step involves examining the camshaft timing itself. Proper camshaft timing is critical for ensuring that the engine runs smoothly and efficiently. Use appropriate tools to verify that the camshaft alignment corresponds to factory specifications. If the camshaft timing is confirmed to be accurate, you will proceed on to the next troubleshooting step. If any discrepancies are identified, resetting the camshaft timing will be necessary to align it correctly. This step is crucial because improper timing can lead to reduced power output, increased emissions, and potential engine damage if left uncorrected. In the seventh step, you must inspect the cam chain for any signs of damage or stretch. A cam chain that is either worn or damaged may lead to issues with engine timing, which could subsequently trigger DTC P0366 due to incorrect phase detection. Carefully examine the cam chain for any visible defects, such as fraying or unusual wear patterns. If the cam chain is found to be damaged or stretched, it will need to be replaced. along with the automatic tensioner. If equipped, this preventative measure is crucial. A compromised cam chain can lead to severe engine performance issues and even catastrophic engine failure if not addressed. Regular inspection can mitigate these risks. The 8th step focuses on inspecting the VTC actuator B, which plays a significant role in the VTC system's operation. Ensure to evaluate the actuator condition thoroughly. A functioning actuator is vital for changing the camshaft timing dynamically based on driving conditions. If the actuator is found to be malfunctioning, a replacement is necessary to restore optimal VTC system functionality. Addressing this step is important, as a faulty actuator can cause issues similar to those related to incorrect timing, ultimately affecting engine performance. Ensuring that all components related to the VTC system are in good condition is essential to preventing subsequent problems. The final troubleshooting step involves conducting a thorough check of the programmed fuel injection (PGM) system. Start by turning the vehicle to the on mode and reset the powertrain control module (PCM) using the HDS. This step is essential for clearing any residual data that could be causing issues. Following the reset, proceed with the CKP pattern clear procedure, ensuring that the system can recalibrate itself properly. Then, perform the PCM idle learn procedure followed by the CKP pattern learn procedure to finalize the recalibration. After these procedures, start the engine again and allow it to idle without load for a confirmation of the current DTCs. If DTC P0366 is indicated once more, it suggests a potential issue with connectivity at the VTC oil control, solenoid valve B, or the PCM. If the DTC does not reappear, then the intermittent failure may have been resolved through these checks. In the final repair verification step, it's crucial to recheck for any DTCs using the HDS. This will help confirm that the initial error associated with DTC P0366 has been fully addressed. After rechecking, ensure that the system is functioning correctly without any lingering issues. Performance tests should indicate that the engine is operating smoothly without any irregularities. If everything checks out and there are no further alerts from the HDS, the repair process can be considered successful. Documenting all actions taken during the troubleshooting procedure is important for future reference and helps maintain vehicle records. Preventive maintenance is vital in avoiding issues related to DTC P0366 in Honda Accord models from 2017 to 2023. Regular sensor checks can help ensure that both the CMP and CKP sensors are functioning correctly, thereby preventing future phase detection errors. Furthermore, monitoring the quality of engine oil is essential, as degraded oil can affect the operation of the VTC system and its components. Scheduling timing belt or chain changes at recommended intervals is also crucial, as worn timing belts or chains can lead to misaligned sensors. Lastly, maintaining good electrical connections will help prevent sensor issues due to improper signaling. By implementing these preventive measures, vehicle owners can enhance engine performance and extend the longevity of their Honda Accord. In conclusion, the Diagnostic Trouble Code DTC P0366 presents a scenario of CMP sensor B and CKP sensor mismatch impacting engine performance in Honda Accord models from 2017 to 2023. A thorough understanding of the symptoms, potential causes, and comprehensive troubleshooting steps is critical for effective diagnosis and repair. We have traced the approach from problem verification to the final checks. ensuring no stone was left unturned in identifying and rectifying the issue. Additionally, preventive maintenance plays an essential role in avoiding future occurrences of this issue, emphasizing the importance of regular inspections and maintenance practices. Ultimately, taking proactive measures will help maintain optimal performance and reduce the chances of engine trouble. Please like and subscribe to the channel. See you next time.